Hello everyone, welcome back to my YouTube channel Chemistry Pocket. I am your chemistry mentor Sreelatha. In this video, I am going to give some more tricks regarding dipole moment. So already in my previous video, I explained some tricks of dipole moment. So please watch that video before watching this video. So please watch that video. So the link is there in the description box. Okay, now let's recall the previous video main points. So dipole moment is nothing but measurement of bond polarity is called as a dipole moment. So it is a vector quantity. So vector quantity is nothing but it have both magnitude and direction. And the formula to calculate to measure the dipole moment is mu is equals to q into d. Q is nothing but charge and d is nothing but distance between two charges and the units are dB. Now let us see the tricks which I explained in the previous video. Okay. Tricks of dipole moment. The first one is dipole moment is directly proportional to electronegativity differences. So dipole moment is directly proportional to electronegativity difference, and also dipole moment is inversely proportional to bond angle, and dipole moment of homoatomic molecule is 0, and dipole moment of cis form is always greater than the trans form. So already I explained these 4 tricks in my previous video. So if you want to watch that video, please check the link in the description box. Okay, now let us see the next trick of dipole moment. So if a molecule is having 0 lone pairs, so 0 lone pairs means the net dipole moment of that molecule is always 0. Suppose take a molecule, if that molecule does not contains any lone pairs means the net dipole moment of that molecule is always equals to 0. So dipole moment of molecule having 0 lone pairs is always 0. So for this one, take an example of, so here we can take the number of examples. So those examples as CO2, BeF2, BF3, PCl5 and CCl4. So number of examples we can take. So take any molecule if does not contains any lone pairs means we can take those examples under this category. Suppose take CO2. So write the CO2 structure. In this one, the central atom is carbon and oxygen is there like this. Okay. Now oxygen is more electronegative than carbon. So now we have to calculate, we have to measure the dipole moment in this direction from carbon to oxygen. From this one, for this one also from carbon to oxygen. So both are present in opposite direction. So the net dipole moment is equals to 0. Net dipole moment is equals to 0. For BeF2 also, BeF2. So here fluorine is more electronegative than beryllium. So from beryllium to fluorine and from beryllium to fluorine. So mu is equals to 0. Like this we can write the structures of remaining also. So then we can get the net dipole moment is 0. Okay. Next one is the dipole moment of a molecule having one lone pair. Suppose if a molecule is having one lone pair means, so the dipole moment for that type of molecule is always not equals to 0. Not equals to 0. If a molecule is having 0 lone pair means mu equals to 0. If a molecule is having one lone pair means always not equals to 0. Always not equals to 0. That means dipole moment is not equals to 0. So for this one, take an example as NH3. NH3. So in NH3, draw the structure. Hydrogen, hydrogen, hydrogen. One lone pair electrons are there. So one lone pair is there. So we should write like this. Here hydrogen is less electronegative than nitrogen. So in this direction we should measure. Okay. Next from atom to lone pair. So already I explained. So we have to measure the dipole moment in which direction means from atom to lone pair. From atom to lone pair. See here, these two will get cancelled and these two we should add. Okay. So that's why mu is not equals to 0 for this molecule because of having lone pair of electron. So here lone pair of electrons are there and here these two dipole moment, that means mu1, mu2, mu3, mu4 is there. No, two dipole moments will get cancelled and 2 dipole moments we should add. It is nothing but mu is not equals to 0. And the next point is dipole moment of a molecule having 2 lone pairs. So if 2 lone pairs are there means if no more lone pairs means mu equals to 0. If one lone pair is there means it is not equal to 0. But if a molecule is having 2 lone pairs means it may equals to 0 or it may not equals to 0. So it should based on its structure. So for this one, take an example as water molecule. First, water molecule. So in this water molecule, draw the structure: oxygen, hydrogen, and it is having lone pair of electrons like this. Now measure the dipole moment. So hydrogen to oxygen and hydrogen to oxygen. And next oxygen to lone pair, oxygen to lone pair. See here, for this one, mu value should not be equals to 0. Sorry. Mu is not equals to 0. Okay. So we should add mu1 plus mu2 plus mu3 plus mu4. Or we can take, so in the resultant dipole moment will takes in this direction and in this direction. So here we should add all dipole moments, so that's why mu is not equal to 0. And next take one more example as XeF4. XeF4. For this xenon tetrafluoride, draw the structure first. So xenon to fluorine, because fluorine is highest electronegative element, and next here also in this way, here also in this way. But here atom to lone pair, xenon to lone pair, xenon to lone pair. See here, for this one all dipole moments will get cancelled. See here, for these two the resultant dipole moment we should take in this direction, and for these two the resultant dipole moment we can take in this direction. So both will get cancelled because both are present in opposite direction. And here also for lone pair of electrons also, one is in upward direction and another one is in downward direction. So both will get cancelled. It is nothing but the resultant dipole moment is equals to 0. The resultant dipole moment of this molecule is also equals to 0. So if molecule contains 0 lone pairs means it is always equals to 0. Dipole moment is always equals to 0. If a molecule contains 1 lone pair means it is always not equals to 0. But if a molecule contains 2 lone pairs means it may equals to 0 or it may not equals to 0. So depending on the structure of molecule we can calculate, we can say that the net dipole moment is equal to 0 or the net dipole moment is not equals to 0. Next, one more question is there here. I will give one question. So which is having, so in between NH3 and NF3 which is having more dipole moment. Let us see here. So to know the dipole moment, first you have to draw the structures N, H, H, H and lone pairs. And for NF3 also F, F, F and lone pairs. So in NH3, so we should calculate the dipole moment in this direction and here in this direction. Okay. And here nitrogen to fluorine, nitrogen to fluorine, nitrogen to fluorine, and here atom to lone pair. That means, see here to find the dipole moment we should add all dipole moments, net dipole moment. If you want to find the net dipole moment means we should add all dipole moments. So there is no cancellation of dipole moments in NH3 molecule. And in NF3, so these two dipole moments will get cancelled because of the opposite direction. Okay. And so that's why always NH3 dipole moment is greater than that of the NF3. So both are having the same, that means number of atoms are same and number of lone pairs are also same. But due to the additive, NH3 is having more dipole moment. than NF3, and here additive dipole moment is takes place, and here subtractive dipole moment will takes place. So it is about the dipole moment. So let us recall the all points. The dipole moment is directly proportional to electronegativity difference. That means if the electronegativity difference is increases, dipole moment value is also increases. And the dipole moment is inversely proportional to bond angle. If the bond angle is increases, dipole moment value is decreases. And next one is dipole moment of homoatomic molecule is 0. Why the homoatomic molecules are having dipole moment as 0 means there is no electronegativity difference in between the same atoms. Because same atoms are having same electronegativity, the electronegativity difference is 0, so that's why the dipole moment is also 0. Dipole moment of cis form is always greater than trans form. Next, if the molecule is having 0 lone pairs means dipole moment is always equals to 0. If the dipole moment is if the molecule is having one lone pair means the dipole moment is always not equals to 0. If a molecule is having two lone pairs means sometimes it may equals to 0 and sometimes it may not be equals to 0. So depending upon the structure we can calculate the dipole moment. So it is about the dipole moment and its tricks. That means tricks to measure the dipole moment. So please subscribe my channel and please like and share my videos. Thanks for watching.